Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Today we are going to do class 10th subject physics. Topic of today's lecture are we will solve we will do MCQs and then numerical 1.1 to 3. We will do mention 3. 1 to 3. Today we will do numerical 1, 2, 3 and the MCQs first. First, I will do the MCQs for you first. First MCQ is choose the correct answer from on page number. This is MCQs that are on page number 16 of your 10th class textbook. Choose the correct answer from the following choices. Which of the following is an example of simple harmonic motion? For the choice 1 is the motion of a simple pendulum. B, the motion of a ceiling fan. C, the spinning of the earth on its axis, and D is a bouncing ball on a floor. The right choice is A. Though first MCQ's answer for first choice is A. Second second MCQ is if the mass of the bob of a pendulum is increased by a factor of 3, the period of pendulum's motion will. Choice 1 is B increased by a factor of 2. B remain the same, C be decreased by a factor of 2, and D choice is B decreased by a factor of 4. The right choice is B. Third MCQ is which of the following device can be used to produce both transverse and longitudinal waves? First choice is a string, the second choice is a ripple tank, C a helical spring, or D is a tuning fork. The right choice is a helical spring, which is the choice C. Waves for MCQs number 4, waves transfer. First choice is energy, second choice is frequency, third choice is wavelength, and the fourth choice is velocity. So our answer is A, which is energy. So fifth MCQ is which of the following is the method of energy transfer? First one is conduction, second one is radiation, third choice is wave motion, and fourth choice is all of these. So the right choice of MCQ's fifth is all of these. Sixth MCQ is in a vacuum, all electromagnetic waves have the same. First choice is speed, B is frequency, C is amplitude, and D is wavelength. So A is the right choice for MCQ 6. 7 MCQ is a large ripple tank with a vibrator working on a frequency of 30 Hz produce 25 complete waves in a distance of 50 centimeter. The velocity of the wave is, first choice is 53 centimeter per second, B is 60 centimeter per second, C is 750 centimeter per second, and D is 1500 centimeter per second. So my choice D is the right one. 8 choices, 8 MCQ is which of the following characteristic of the wave is independent of the others? First choice is speed, the second is frequency, third is amplitude, and D is wavelength. So C, which is amplitude, is the right choice for MCQs 8. Ninth, the last one MCQs. The relation between V, F, and lambda of the wave is, first choice is V, F equals to lambda, B equals to F times lambda equals to V, and C choice is V times lambda equals to F, and D choice is V equals to lambda by F. So in this MCQs, ninth one, which is the last one of MCQs, which is D choice, F lambda equals to V. It is the right choice for ninth MCQs. So this is the end of our MCQs. Now I am going to start numerical of chapter number 10. The numericals are on page number 17. I have solved the numericals for you. So if I take the first numerical, we solve the numerical 10.1. I read the numerical first for you. The time period of a simple pendulum is 2 seconds. What will be its length on the earth? What will be its length on the moon? if gm equals to ge divided by 6, where ge is equal to 10 meter per second square. So in this numerical, given data is time period is given to us, which is 2 seconds. You know the time period of the unit of time period is second. So time period is given to us, given data, time period is equal to 2 seconds. Acceleration due to gravity, why I am writing E, because acceleration due to gravity on Earth. So it is 10 meter per second square. This is understood. Acceleration due to gravity on Moon, which we can find with the help of this formula, gm equals to ge divided by 6. So ge is the acceleration due to gravity on Earth. You know, I use this one, 10 meter per second square. 10 divided by 6 equals to, if you solve this, this is gonna be 1.67 meter per second square. Acceleration due to gravity on Moon is 1.67 meter per second square. So the next one to find, we need to find these things. Length on the Earth. So since it is the length on the Earth is not with letter LE. E stands for Earth. So length on Earth we need to find out. Length on Earth we need to find out. Sorry, we are on the wrong slide. Right. This one, length on Earth. Length on Earth is LE and length on the Moon is LM. I use this formula when we studied the this chapter. We studied this formula. Time period is equal to 2 pi under root L over G. So if I taking the square on both sides, if I take the square on both sides, so T square is equal to 2 pi LEGE whole square. Next, if I took the square, to T square equals to, if I separate this out, since we want to find out LE, separate LE from the given formula, LE equals to T square GE 4 pi square. I just put the value, T value is 2 and value of G on Earth is 10 and 4, this is 4 and pi, value of pi is 3.14 whole square. So if you 2 square is 4 and 4 will be cancelled with this. So 10 divided by 3.14, first of all you will take 3.14 square, which is 9.86. 10 divided by 9.86, you will get length on Earth is equal to 1.02 after rounding off. Your unit of length is meter. Again, since I want to find out length on Moon as well in this numerical, so I use the same formula, but this time I replaced LM and GM because I want to find on the length on Moon and acceleration due to gravity on Moon. So take the square again with this equation and separate out LM, which is the length on Moon, because I want to find out length on Moon. Just plug in the values. You know the value of time period is 2, 2 square is 4. So 4, this 4 will be cancelled with 4. 3.14 square is 9.86. If you 1.67 divided by 9.86, it's gonna be length on Moon is 0.17 meter. So our result will be length on Earth is 1.02, which we found this one, and length on Moon is 0.17 meter. So this is the end of the first numerical 10.1. Now we move towards second numerical, which is 10.2. I read the numerical for you first. A pendulum of length 0.99 meter is taken to the Moon by an astronaut. The period of the pendulum is 4.9 seconds. What is the value of G on the surface of Moon? In this numerical, we need to find out value of G, acceleration due to gravity on Moon. So what is given? First of all, I will write given data. Length of pendulum is L, 0.99 meter. It is given to me. Time period is also given to me, which is 4.9 second. Acceleration due to gravity, which is on Earth. Since it is on Earth, that's why I'm placing E. Underneath G, G equals to 10 meter per second square. So in this numerical, what we are going to find value of the acceleration due to gravity on Moon. Sorry. Uh, we will use the same formula which we did in the 10.1 numerical. Same formula will be used in 10.2 numerical as well. So if we take the square on both sides, so T square is equal to 4 pi square L over GM. Now we did it in the last numerical as well. So if you, since we want to find out gm, value of g, acceleration due to gravity on moon, that's why I am separating this out. I separate this gm out. 4 pi square L over t square. 4 pi value is 3.14 and length is given to me 0.99 and where time period is given to me 4.9 square. Just plug in the values and you will, after solving this, you will get value of g on the surface of moon is 1.63 meter per second square. Student, you must know the value of g on earth is 10 meter per second square, but if you take the any object on the moon, the value will reduce to 1.63 meter per second square. On the surface of the moon, the value of acceleration due to gravity is 1.63 meter per second square. So our result will be 6 acceleration due to gravity on moon is 1.63. This is the end of the numerical 10.2. Next numerical 10.3, given data. I read the numerical for you first. Find the time period of a simple pendulum of 1 meter length placed on Earth and on a moon. The value of G on the surface of moon is 1 by 6 of its value on the Earth, which is Ge is equal to 10 meter per second square. So this numerical is on page number 18 of your 10th class textbook. So first of all, I write the given data. Length of simple pendulum small l equals to 1 meter. Acceleration due to gravity. You know the acceleration due to gravity on Earth is Ge. Wherever Ge I have written Ge mean Earth. Acceleration due to gravity. You know this, understood. You know it very well. In the ninth class, we read this a couple of times. So Ge is equal to 10 meter per second square. Value of G on the surface of Earth is 10 meter per second square. But how will we find the value of G on the surface of moon with the help of this formula? The value of G on the surface of moon is Ge, the value of G on the Earth divided by 6. So value of G on the Earth is 10 divided by 6. If you divide 10 divided by 6, we will get 1.67 meter per second square, which is the unit of acceleration due to gravity. In this numerical, what we are going to find time period on the moon. Time period is since we want to find out the time period on moon. That's why I'm placing m. A time period on Earth, I'm placing e small e as a subscript. So te and tm, this we need to find out. So the formula will be same as we discussed is 10.1, 10.2 numerical. The formula will be replaced. Only the things you need to notice. Tm mean time period of moon and gm mean acceleration due to gravity on moon. So I'm just putting the values. So L is given to me 1 meter. So I'm placing 1 meter. Gm equals to 1.67. I'm just putting 1.67. With the help of your calculator, if you take 1 divided by 1.6 and then take the under root, and whatever the value, whatever the result will come, just multiply with 2 and 3.14, you will get time period on moon is 4 seconds. Time period on the moon is 4 seconds. You know the time unit of time period is second, so time period on moon will be 4 seconds. Next, again we need to find out in this numerical time period on Earth. So same formula, but here I am writing E and G. The value of G on Earth and the time period on Earth. So L is same. L will be remain same. L is 1. Value of G on Earth, you know, this is understood value 10. On Earth is 10. If you 1 divided by 10, you will get 0.1. If you 1 divided by 10, you will get 0.1. Taking the under root square root 0.1, and whatever the result will come, whatever the answer will come, multiply with 2 and 3.14. So our TE will be 2 seconds. So our result will be time period on Earth is TE 2 seconds, time period on moon is TM, which is 4 seconds. So we did numerical 10.1, 10.2 and 10.3. Inshallah, we will do in our next lecture, we will start our numerical from 10.4 and do onwards. Thank you very much.